We're going to do a couple examples of when the central atom on a Lewis structure has more than an octet. This can happen periodically, and it's usually for these three reasons that are outlined. Okay? Here, you just have so many electrons that extra electrons go on the central atom. We still follow our rules. Here, you have more atoms bonded around the central atom than you would typically have. And then here, it actually improves the formal charges when you violate the octet rule. So I've added up the number of electrons for these three examples, and we're going to follow our rules just like normal. So we've added them up. I'll pick a central atom. It's usually written first. So I connect all the atoms with a single pair. That uses up 4 electrons. I have 18 left. I fill in my terminal atoms till they have octets. That uses up 12. And remember, every leftover electron goes on the central atom. So 1, 2, 3, 4, 5, 6. That leaves me with no electrons. Because it's a polyatomic ion, I am going to put a charge on it, some brackets around it. That is the correct Lewis structure for that polyatomic ion. Now, for PCl5, same thing, but you can see there's 5 atoms that look like they're around the central atom, and that is okay. So I'll put the phosphorus, and I'll put all of these chlorines around the central atom. That uses up 10, and I'm left with 30 electrons. I have 5 terminal atoms, all which need 6 electrons, and so 6 times 5 is going to use up all my electrons. And I used up 30. I have 0 left. One of the ways you can check this is if you look at the formal charges for these, phosphorus is in group 5, and it has 5 electrons assigned, 1 from each bond, so it has a 0 formal charge. And all the chlorines came in with 7, and they have 7 assigned, so every atom in this structure has a 0 formal charge. Remember, atoms in period 3 or higher, meaning higher on the periodic table, 4, 5, 6, they can have expanded octets. They can violate the octet rule. This last one is an example of you connect all the atoms, and you can draw a perfectly fine Lewis structure that uses up 8, 24 electrons. And this looks great. Everything has an octet, and it's just fine. When you calculate the formal charges on this, you're going to expect some formal charges because it has a -3 charge other than 0. So when you calculate these, they're all, this is 6 minus 7 is -1. So all of these are -1. And this would be 5 minus 4, or +1. One of the things you can do, though, because phosphorus is in period 3 or higher, you can pull one of these sets of electrons in and make a double bond. And so they're no longer there. But what would happen now is this wouldn't be the formal charge. It would be 6 minus 6, or 0. And this now would be 5 minus 5, or 0. So we violated the octet rule for this structure, but we did it because it improved the formal charges, and it's an atom that can have an expanded octet.